GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. It is most expected problem. Very, very important problem. I can say 5-star problem. This kind of problem can be repeated. Asking like this. Calculate the acceleration of the block and trolley system shown in figure. Look at the trolley and block. The coefficient of kinetic friction between the trolley and surface is coefficient of kinetic friction is given 0.05. Acceleration due to gravity g equal to 10 meter per second square, and mass of the string negligible. The string, its mass is 0. Mass of the string is 0. We are asked to decide what is the acceleration. Acceleration A equal to how much? For that, first look at the block. Block weight is acting vertically downwards. That is 2 into g. Whereas tension is acting in this direction and block may moving in this direction with acceleration A. Since the same string is connecting, tension is remaining same. With respect to trolley, the tension is acting in this direction and kinetic friction is acting in this direction. For that, the weight of the trolley is 10 times the g and the normal reaction direction. This normal reaction must be balanced by 10 times the g. Then this mu k equal to kinetic friction, coefficient of kinetic friction multiplied by n. N. Now, first let us take the trolley. For the trolley, here, since the block trolley is moving in this particular direction, here T is more than the kinetic friction. Therefore, the T minus kinetic friction must be equal to mass of the trolley, that is 10 times the acceleration. From this T equal to kinetic friction plus 10 times the A, can also be written as T equal to kinetic friction is what? Mu times the K into N plus 10A equal to mu K into N equal to 10G. 10G plus 10A. Simplify it. Mu 0.05 into 10 into G value also 10 plus 10A. 10A. It is equal to 100 into 0.05. 5 plus 10A. That is the tension on the string with respect to trolley. Let this is the relation number 1. Similarly, with respect to block. For the block, for the block, you know, this 2 times the gravity constant is acting vertically downwards, minus tension is acting upwards. It must be equal to mass of the block, that is 2 into acceleration. 2 into 10 minus t is equal to 2a. From this t equal to 20 minus 2a. Let this is relation number 1. Already you got equation 1. T equal to 5 plus 10a. T equal to 5 plus 10a. This we are assuming as 1. Now compare the 1 and 2. LHS are equal. You can equate the RHS from 1 and 2. I am equating the RHS. 5 plus 10a must be equal to 20 minus 2a. 2a. From this 10a plus 2a is equal to 20 minus 5, that is equal to 15. So 12a is equal to 15. From this acceleration equal to 15 divided by 12. You simplify this value for getting around 1.25 meter per second square. That is the acceleration of the system. Look at the options. Option A itself is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. Two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. Look at the two bodies. This is the body 1. This is the body 1 of mass m1 equal to 4 kilograms. The another body, that I can say body 2 of mass m2 equal to 6 kg. Okay, this is the string. This is the string. The string passes over a pulley which is frictionless. Okay, the pulley is rotating without friction. See in the figure, the acceleration of the system in terms of acceleration due to gravity is, you're asked to decide acceleration of the system in terms of acceleration due to gravity. For that, we need to decide the net weight of the system. Weight of the body 1 equal to m1 into g. Weight of the body 2 equal to m2 into g. Net weight net weight equal to w2 minus w1. Since mass 2 is more than mass 1, definitely it is moving towards the mass 2 with acceleration a. Then this weight must be equal to mass times the acceleration is equal to w2 minus w1. Here mass equal to m1 plus m2. m1 plus m2 into acceleration equal to w2 minus w1. Then acceleration a equal to w2 m2 minus m1 into g divided by m1 plus m2. You substitute the values. m2 equal to 6 minus 4 divided by 6 plus 4 multiplied by g. It is equal to 6 minus 4, 2 divided by 10 into g. It is equal to g by 5. That is the acceleration in terms of acceleration due to gravity. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Look at this problem. Asking like this. A body of mass m is kept on a rough horizontal surface. Coefficient of friction is mu. Horizontal force is applied on the body, but it does not move. It is like this. There is a rough horizontal surface. Over that rough horizontal surface, a body is placed. This is the body of mass m means this is the center of gravity g. Weight is acting vertically downwards. And look at the contact surface. This is the contact surface. Perpendicular to that contact surface, normal reaction is developing. That is denoted with capital N. Normal reaction, that is represented with capital N. And horizontal force is applied like this. This is the horizontal force. Then, since it is a rough surface, frictional force is developed in this particular direction, opposite to direction of force applied. This is the frictional force F. Then, the resultant of normal reaction and the frictional force acting on the object F is. So, what is the resultant force between the normal reaction and frictional force? For that, as you know, the frictional force F equal to mu into N. But look at the N must be balanced by mg. So it is equal to mu mg. Okay. Then the resultant force between the normal reaction and frictional force may be in this particular direction. Let me mark it clearly. This may be the resultant force F, and I can say this is the frictional force. Then that no, that resultant force F must be equal to F square, right? F square, resultant force square equal to F square plus N square. That is Pythagoras theorem. Okay. From this, F equal to root over F square plus N square. It is equal to root over F equal to mu mg. mu mg whole square plus n equal to mg whole square. Write the mg outside, then it is root over 1 plus mu square. That is the resultant force between the frictional force and normal reaction. Look at the option C. Option C, mg force is less than or equal to mg into 1 plus mu square. Right? That means, so this is the, right, this must be the horizontal force required. Okay. Similarly, shall I take the next question? Yes.
GeopByte.